Good afternoon, and welcome to your science review with Mr. Blades. Today we're working a page out of a recent test for my course, so let's go ahead and get started. Part B asks, what is the upward force exerted by the scale called? That is just our normal force, Fn. Again, normal refers to the direction, and in this case it's opposite to the force of gravity pressing down. So there we go. Next, it asks us to draw the free body diagram for the person accelerating upward. Okay, so we have our box. Downward, we have our force of gravity, and upward, we have our normal force. This free body diagram is for the person inside the box, and that is all the force they are experiencing. No tension, no nothing else except gravity and the normal force. Next, it asks us for the person's mass. That is most easily solved for using our equation Fg is equal to mass times the acceleration due to gravity. We know our force of gravity, and we know our acceleration. So we're able to plug those into our equation, where 800 is our force of gravity. 800 is equal to our mass, whatever that is, times 9.8 meters per second squared. That's the acceleration due to gravity. We divide both sides by 9.8 meters per second squared, and we solve for a mass of 81.63 kilograms. Next, it asks us the elevator accelerates upward with a rate of 2 meters per second squared. What does the scale read? Show your work. Again, the reading of the scale is going to be equal to the normal force, or how hard the scale is pushing up. So let's go back to our free body diagram and our summation equation and write that down. Normal force plus the force of gravity equals mass times acceleration. We're given an acceleration for that part of the problem, and it's 2 meters per second squared. So we can plug that in, and we've already solved for our mass, 81.63 times 2 meters per second. And we've already solved for our force of gravity. Plug that in. That's 800. But let's go ahead and make those negative, since the force of gravity is opposite in direction to the normal force. So we have normal force minus 800 newtons equals 81.63 times 2. Add 800 to both sides, and we solve for normal force is equal to 963.23 newtons. There we go. Put a box around our answer. Next, if the elevator moves at a constant speed of 5 meters per second, what does the scale read? Now, that is another way of saying that acceleration is equal to 0. So a constant velocity means our acceleration is equal to 0. There we go. We use our summation equation again. Sum of forces is equal to normal force plus the force of gravity equals mass times acceleration. But we have an acceleration of 0, so that product just becomes 0. Now we have our normal force minus 800 newtons, like we did before, equals 0. So our normal force is again 800 newtons. Now, G, during the acceleration in part E, the scale reads greater than, equal to, or less than the scale reading when the elevator is at rest. But when you're in an elevator accelerating upwards, it feels like you are heavier. So we can intuitively say that the scale will read greater than as the elevator accelerates upwards than it would when you were at rest. I hope this was helpful. I'll see you in class.